I'm in class 11th at AKS DVHS's Pioneer, and I am here in front of you with the seminar on the topic scientist and his inventions related to the Mole Day celebration. And I have taken the discovery of electrons by Michael Faraday. And Michael Faraday is a popular scientist, as most of the people knows. And Michael Faraday was born on 22nd September 1791 and died on 25th August 1867. He got the awards. The awards got by him was Royal Medal Award and Albert Medal, etc. Many medals were get by him, Michael Faraday medal was also got by him. And the main discoveries by Michael Faraday was electromagnetic induction, diamagnetism, and electrolysis. These are the main discoveries by Michael Faraday. Next, he worked in the fields of physics and chemistry. He contributed a great part of himself in both the physics and chemistry parts. I am going to explain the discharge tube experiment, which led Michael Faraday for the discovery of electrons. Discharge tube experiment is like this, that is, he taken a discharge tube which is made up of glass, and the discharge tube is also known as cathode ray tube. Inside the discharge tube we have two electrodes. Okay, these two electrodes are there, and the electrode which is connected to the negative terminal of the battery is called a cathode, and the electrode which is connected to the positive terminal of the battery is called anode. And inside this we have some cathode rays, and that happens during high voltage and low pressure. When high voltage and low pressure, some rays move from cathode to anode, and these rays are called cathode rays. And one more thing to explain in the discharge tube is that we have a vacuum pump to adjust the gas inside this discharge tube. These rays, I have already told that these rays are called cathode rays, and which moves from cathode to anode, and they move in a straight line, and during the presence of electric and magnetic field, they act as negatively charged particles, hence they are called as electrons. That's how the electrons are discovered. Now, this cathode rays, when passed through this anode, when it hits the anode. Now I am going to make some holes in this anode now. So when I make some holes, it passes through this anode. It passes when I make holes. So when it passes through these holes, and here I have just got it with a zinc sulfide like fluorescent material. Zinc sulfide like fluorescent material or phosphorescent material. Zinc sulfide is a fluorescent material or phosphorescent material which I have got it here, and in that when the cathode rays come and hit, here we can see some brightness, that means some light differences, and this we can see the presence of this cathode rays touching this metal means phosphorescent material. Sorry, metal not, it's phosphorescent material. We can identify the presence by using phosphorescent material like zinc sulfide. Zinc sulfide is an example of phosphorescent material, and that's how the presence of cathode rays can be identified. And this cathode rays can pass through the metal foils also. Hope you like my small effort on Faraday's discharge tube experiment. Thank you.